All right. So, did you come up with anything? Maybe if you're watching this, you're probably hoping I'm going to give you the answers. Well, I will. So, basically, this is not a super efficient way because, remember, it goes forward and sleeps and it relies on sleep to do all of its movements, which means that if someone decides to move the walls, it's not going to be very helpful. We aren't using the sensor. Remember, there's a sensor at the front. How do we get that working? So let's think about it. Basically, we need it to move forward until it sees until the sensor triggers. And then, once the sensor triggers, it needs to stop. So, instead of using sleep for moving forward, we need to actually have it keep going for basically as long as it needs to. So I'm going to delete this sleep here. And I'm going to also comment out all of this part. This is the code that we're not using. I'm going to use what's called a multi-line comment. You do a slash followed by a star. And then down here you go star followed by a slash. Everything inside here is commented, and the cool thing is I can just do this and hide it all, so I don't have to worry about it. So now we still have the spin, because I mean we can still use it if we want to, but we need to control when to stop spinning. So let us think of a way, and what we can do is use what's called a while loop. And a while loop basically means you loop while a condition is true. So I can say while true, and then I have what's called a little bracket like this, and then inside here I have whatever situation it is, or whatever I want to have happen that gets repeated. And in this case we just have a sleep of 0, or like sleep ms, and we have like 5 or like 10 milliseconds, basically. And that could be, in theory, basically part of the solution. But the thing is, if I put this in, it's just going to spin forever, because while true means it's going to just while always, because true is always true. Oh, what's wrong? Oh, maybe it's sleep ms with a lowercase. I see. There we go. So it's going to start spinning, and now it's in this loop, and it's never going to get out of the loop. It's just going to stay there forever. You can see that the motors are both still turning. I don't know, it must have slipped off the button and started going that way, but it's not going to stop. So what we need to do is we can keep this, but we need instead of while true, which means just go forever, we need it to be while the condition is true or false. So what we could do is we could have it be based on the bumper. So we could say, basically to get something from the bumper, what we have to do is we have to use bumper a dot value, and then returns an integer or returns the value of the bumper. And what else does it say here? Let's read it. And a value of 1 is on and value of 0 is off, which it doesn't say. So basically, if we go in here, we say we're going to create a variable, integer, bumper value equals bumper a dot value. And then we put a semicolon here. Don't forget to always put your semicolons. And then we have a bumper value, which we can then put into our loop. So we have while bumper value is 0. We sleep. And then this part, which is the stopping, telling the motors to stop. So then hopefully it'll get to this point and we'll know when the motors stop. So let's move this back over here. And let's run it. And so we'll check the value of the bumper over here. And did not look like it stopped. Of course it didn't, because this only checks the value once. What we need to do is we need to actually check the value every single time we loop. So what we should do is actually take this part, the bumper a.value, actually copy it and put it here. And then we can get rid of this part. So then we have while bumper a.value is equal to 0. That way it's actually checking it every time it repeats. So basically it's going to spin both motors forever. Then it's going to get to here and go inside and sleep and sleep and sleep and sleep. And it's going to keep repeating until this is no longer true. And then it's going to jump to here. So let's try it again. There we go. And it stopped. We can see that there's some problems with the bumper, which I think is to do with it moving too fast. So let's change the speed a little bit as well. Go down. Let's drop our speed down. And then once we've stopped, we want to back up a little bit. So once we back up, we're going to go, well, let's do left motor dot. And instead of spin, we're going to do, there's a few other functions you can use. You can use start rotate. You can use start rotate 2 or rotate 4, and those will actually give us. And let's use rotate. Let's use start rotate 4, and that's going to give it a certain amount of rotation, so we can tell it to actually rotate for a specific amount of time. So we have start rotate 4. And then in here, we're going to go, actually, let's use, there's another one called just rotate 4, I believe. So it goes rotate 4. And this one we can pass in the wait for completion function, or Boolean. So then we go the amount of rotation, so we're going to go negative 90, let's say, degrees. And then DEG. But we might have to do the vex : rotation units, degrees, comma, and then what else do we need? We need the velocity. So let's go 10 vex, and then we can do PCT, and then we have to go false for wait for completion, and then semicolon there. And then the other one, we're going to wait for completion. So we go here, copy this, make this be right motor. And then this will be true, which means we're going to wait for completion of the right motor. And theoretically, both motors should be done. Now, this isn't perfect in all situations, and there's another way to solve this so that it waits for completion of both. But for simple programs like this, should be fine. So now we run the code again, and it should rotate, and both motors should go backwards once it touches the wall. Oh, and of course, there's another error. Don't be afraid. There's always errors, and you can always try to find it. No matching member function for call to rotate 4. Did I spell it wrong? Oh, maybe because I'm not using enough parameters. Let's see. So it should be, zoom out more so we can read the whole thing. Double rotation, vex rotation units, double velocity, vex velocity units, and then maybe I have to go vex velocity units percent, like that. For some reason, some of these work and some of these don't. I don't know why, but that's just the way it is. And then run. Yeah, PCT works for spin, but it doesn't work for the... it's very inconsistent. Okay, now we're going slow. Touches it. Boop. Backs up. Now it backs up a little bit too far, but I can always tweak that by changing the amount of degrees. So go in here. So change this to maybe be 80 instead. And now we have a very simple... Oh, and the other thing is I want to stop again. So we left no order to stop. Because now see it's drifting all the way back to the front again. So we stop it again. And this is going to be reverse. And then we also can uncomment this. And now we have our turn back. So let's run the code again. So it's going to go, tap, reverse, spin. Not bad, but maybe still a little bit too much reversing. So let's try 50. And let's not stop for so long once we touch the wall. Let's only go like 0.1. So then it should just tap it and back up. So go, 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 tap, reverse, and then spin. There we go. Still a little bit too much. I'm not a huge fan of the pivot point it has, so for when it spins, you might have to play around with it to get the correct rotation that you want for when it's turning. You could try turning just one of the wheels and see how that behaves. But this seems okay for now. I'm just backing up a little bit less. And the thing to point out is after you have this, you should be able to move these walls. I can move this wall anywhere I want. I can move it all the way over here. Then I can run the code. And this is a quick way to test to see that it works. I can move the wall and it'll still go all the way until it reaches the wall. Tap it. And then turn. It doesn't matter where the wall is. I could even put the wall, I could even move it over here. Now, obviously, this wouldn't be very good because then it would get stuck, but it works. So go here, tap it, backs up, and it still turns. So this is the benefit of using a function or using a loop and the sensor rather than just sleep, because it gives us much more flexibility. In the next video, I'm going to show you how to keep adding more to solve the other stages, and then we'll talk about how to reduce some of that repeated code, because you're noticing that like I had to do stop, then I have to do stop again, then I have to do stop again. Well, that's kind of annoying, so there's tricks we can do to fix that. So if you're interested, check out the next video. Thanks for watching.